Hello everyone, welcome to the KVP Physics Academy. Today we are going to the study of the alpha particle. We know that in radioactive elements emits the alpha particle, beta particle and this gamma particle. Okay, is alpha is related to the nucleus of the atom. Yes or no? Now why need to study of this radiation of the alpha particle, or why atoms radiate the alpha particle from nucleus? ओके हम ये जनरल लाइफ से थोड़ा सा रिलेट कर देंगे तो आपको समझ में आएगा कि ये क्यों रिलेट इमिट करता है अल्फा पार्टिकल्स एटम। सपोज आप जनरल लाइफ में देखेंगे, सपोज आप बड़े हो गए थोड़े से तो आप अर्निंग चार्ज स्टार्ट हो जाता है। ये सर जब अर्निंग कर रहे हैं डेली लाइफ में कंटिन्यूसली अर्निंग बढ़ रहा है, ठीक है। जब आपके पास अर्निंग नहीं था, यू आर स्टेबल, लेकिन सोसाइटी के लिए यू आर अनस्टेबल पार्टिकल। यू आर अर्निंग मोर एंड मोर मनी, you become a rich and a richer one. Okay, means आपके पास जितना भी ज्यादा मनी होगा, you are like a stable. Your society see like that you are stable, or own also you like feeling like that you are stable. Yes or no? But one condition is happen at that time. You realize that you are not a stable, you are unstable. You getting the more and more money, you become unstable and unstable particle. Yes or no? मतलब हमारे पास जितनी भी एनर्जी आ जाएगी, जितना भी मनी आ जाएगा, इतने हम क्या बनेंगे? अनस्टेबल बनेंगे। जैसा ना, और जनरल लाइफ में भी आप देखते हैं कि सोनी एग्जाम्पल्स कि जो भी आदमी बड़े होते हैं जनरली वो कहाँ ना कहाँ डोनेशंस करते हैं। अब ये स्कूल में कहीं डोनेशन करेंगे, रूरल एरियाज में कहीं सोसाइटी के लिए कोई फंडिंग कर सकता है, कोई डिफरेंट जो सोसाइटीज वगैरह चलते हैं, कोई मंदिर के लिए डोनेशन देता है। मतलब डिफरेंट एरियाज में आप कुछ न कुछ आपकी एनर्जी डोनेट करते हैं। ऐसा क्यों करते हैं? एक्चुअली आपके पास जितनी भी एनर्जी आएगी, अब तो सोसाइटी के हिसाब से तो आप स्टेबल है, लेकिन आपको रियलाइज हो रहा है कि आप स्टेबल नहीं, अनस्टेबल है। और आप स्टेबिलिटी लाने के लिए क्या कर रहे हैं? सम अमाउंट ऑफ मनी, सम अमाउंट ऑफ एनर्जी डोनेट टू द सोसाइटी। किस लिए? कि आप स्टेबल बनना चाहते हैं। यस और नो? स्टेबल बनना चाहते हैं। ऐसा क्यों? आपके अंदर अनस्टेबिलिटी क्यों आ गई? बिकॉज यू अर्न मोर मनी, यू गेटिंग मोर अनस्टेबल। और फिर आप स्टेबिलिटी के लिए लाने के लिए आप क्या कर रहे हैं? कुछ ना कुछ डोनेशन दे रहे हैं। यस और नो? क्यों? क्योंकि आपको स्टेबल होना है, आपको स्टेबल होना है। सेम थिंग हैपन इन न्यूक्लियस आल्सो. We know that when atomic number is increases or mass number increases, stability of atom decreases. Stability of atom decreases. We know that once you cross the 56, then a binding energy per nucleon graph decreases. Yes or no? And here is a uranium. This one is a more unstable. Why? Uranium is the more unstable because binding energy per nucleon is less as compared to the remaining atoms. यस सर नो? वाई अनस्टेबिलिटी बढ़ गई है इसमें? तो आप देखिए, आपके सेंटर में देखिए हमारा जो एटम है, दिस वन इज इलेक्ट्रॉन मूविंग अराउंड द न्यूक्लियस एंड दिस वन इज अ न्यूक्लियस एट द सेंटर. दिस न्यूक्लियस कंटेन प्रोटॉन्स एंड न्यूट्रॉन्स. Here is a proton, neutron, like that. This is the bundle of proton and neutrons. Okay. Now हमारे पास जो न्यूट्रॉन्स रहेंगे वो तो न्यूट्रल रहेंगे, इसका तो कोई इफेक्ट नहीं होगा, ठीक है। लेकिन अभी न्यूट्रॉन बढ़ रहे हैं, मतलब ये साइज ऑफ द न्यूक्लियस इज इंक्रीजेस एंड नाउ प्रोटॉन नंबर इंक्रीजेस. व्हाट हैपन? प्रोटॉन इज अ पॉजिटिव चार्ज. अब पॉजिटिव चार्ज है जब 2 प्रोटॉन्स है, नेक्स्ट 3 प्रोटॉन्स है, नेक्स्ट 4 प्रोटॉन्स है, जितने भी प्रोटॉन्स बढ़ जाएंगे अंदर का रिपल्शन जो है वो बढ़ जाएगा. सपोज कंसीडर कर ले एक रूम में 50 कैंडिडेट्स है, इसके बीच का रिपल्शन x कंसीडर कर लिया, और नेक्स्ट टाइम आप वही रूम में 100 कैंडिडेट्स डालिए, रिपल्शन और भी बढ़ जाएगा. व्हाई? बिकॉज ये नंबर ऑफ पार्टिकल इज सेम पार्टिकल increases, repulsion is increases. Got it? Repulsion increases. Number of more particles, repulsion is increases, because inside the nucleus proton number is increases, repulsion is increases. This is known as a coulombic repulsion. कोलोमिक रिपल्शन। जितना रिपल्शन ज्यादा होगा उतनी अनस्टेबिलिटी एटम की बढ़ जाएगी, अनस्टेबिलिटी बढ़ जाएगी। ठीक है, अनस्टेबिलिटी कब बढ़ जाएगी? ठीक है, अभी आप देखिए हेलियम है 2 प्रोटॉन्स है, लिथियम है 3 प्रोटॉन्स है। ठीक है, ये प्रोटॉन्स बढ़ गए, कोई प्रॉब्लम नहीं है, लेकिन जब बढ़ते 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 एक लिमिट आ जाएगा, इस लिमिट के बाद और भी प्रोटॉन बढ़ गए तो अभी क्या हो जाएगा? रिपल्शन हो जाएगा। अभी क्या हो जाएगा? रिपल्शन हो जाएगा। सोसाइटी में भी देखिए अभी थोड़ा सा एक 1 लाख पीपल्स है, 2 लाख पीपल है, ठीक है, कोई प्रॉब्लम नहीं, फिर सीआर में हो जाएंगे तो इनके बीच क्या हो जाता है? रिपल्शन होता है। मतलब वो जो सोसाइटी है, जो बॉन्डिंग पहले 1 लाख से थी वो करोड़ से नहीं रहेगी। ठीक है, मतलब जितने भी प्रोटॉन्स बढ़ेंगे इतनी अनस्टेबिलिटी की ओर एटम क्या हो जाएगा? बढ़ जाएगा, अनस्टेबिलिटी बढ़ जाएगी। ऐसा ना, मतलब ये अनस्टेबल पार्टिकल हो गया। ठीक है, अनस्टेबल पार्टिकल हो गया तो उसमें क्या हो जाएगा? वो डिफरेंट एनर्जी में जाएगा। सिंपल सी बात देखिए, यहाँ हमारे इलेक्ट्रॉन्स है, दिस इज मूविंग अराउंड द न्यूक्लियस। सपोज यहाँ वैकेंसी क्रिएट हो गई, ये इलेक्ट्रॉन यहाँ गया तो हमको कुछ न कुछ प्रोटॉन्स मिल जाएंगे हैविंग द एनर्जी, सपोज HNU1, but same proton going to this state to this state, we getting the energy is different of this proton, different of this proton। मतलब यहां से यहां प्रोटॉन गया डिफरेंट जी, x आ गई, यहां से यहां गया एनर्जी x2 आएगी, x2 is greater than x1, means same electron going in a different energy levels getting the different energy of the protons। Similarly in nucleus also how the different energies, means this one is a nucleus, inside the nucleus have different energy levels, and this is nucleus is sitting in a different energy levels। Okay, now so transition from this energy level to this energy, nuclear energy levels of the nucleus, then emitting alpha particle, in this case proton is emitted, in this case alpha particle is emitted। Okay, now nucleus emit this to this region, emitted one alpha particle, suppose emitted one alpha particle, suppose the transition this point, this dotted, suppose we consider this one is a nuclear cell, we're getting suppose alpha particle। Okay, we consider suppose alpha 1 prime, alpha 1 prime। Next, suppose transition from this to this, suppose we can take alpha double prime, alpha double prime, and suppose again one energy levels is another one, suppose transition from this to this, we consider alpha triple prime, alpha triple prime। Okay, this nuclear transition we getting energies alpha 1 alpha prime particle, second alpha double prime, alpha triple prime। What is the difference between these 3 alpha particles? Actually nature of this one is a 2He4, means this one is helium atom or doubly ionized atom, 2He4, here also 2He4, here also 2He4, but all cases, but all alpha particle have different energy, all alpha particle have different energy, got it? Atom will be same, atom will be same, but transition is a different, energy also different of the alpha particle, different of the alpha particle। This energy depends upon lambda constant, means here lambda is larger, energy of the alpha particle also larger, energy of the alpha particle also larger। Now this alpha particle is emitted from this nucleus, alpha particle is emitted from this nucleus, now this suppose alpha going in the direction। Okay, now this one is up to here is a atom, up to here is a atom, now this helium nucleus going in the direction। Okay, and suppose it has some energy and this particle reach up to this point, okay, means this to this distance is known as a range of this alpha particle, okay, this range depends upon which quantities? This range depends upon energy of this alpha particle, like that। Okay, means here is suppose alpha prime have less energy as compared to the alpha double prime, as compared to the alpha triple prime। All cases is a helium atom, but it has a different energy. Why? Because of the transition of the different nuclear energy levels। Okay, now next, this energy level depends upon this lambda constant, depends upon lambda constant। Suppose we consider the alpha 1 have the lower energy, less energy as compared to the alpha 2, means the range for alpha prime is equal to this one। Next, This is the range for alpha double prime, and this is the range for alpha triple prime. Yes or no? Means this distance is less as compared to this distance. This distance is less as compared to this one. Why? Because first alpha have the less energy as compared to the alpha double prime, and alpha double prime have the lower energy as compared to the alpha triple prime. Totally depends upon these are different energy levels. These are different energy levels. Got it? Means in a same atom getting the different energetic alpha particle, different energy alpha particles. And what is the relation between range and energy? Range and energy. E to the power 3 by 2. E to the power 3 by 2. Okay. Means this is the relation between energy and range. Energy increases, so definitely range also increases. Yes or no? This totally depends upon these energy levels. Or directly proportional to this one. And this energy depends upon this lambda constant. This is depends upon lambda constant. Okay, means here Re and lambda also some relation. What is the relation between them? Log lambda is equal to A plus B log R. A plus B log R. Yes or no? This is known as Geiger-Nuttall laws. Okay, lambda and R relation. Lambda and R relation. What is that? E and R relation, and E and some lambda relation. Then lambda and R also some getting relation. We can substitute the E also here. Okay, but here only what is the change? R is directly proportional to E to the power 3 by 2. Means here we get E to the power 3 by 2. Next, we know that ln A to the power B. This can be written as B ln A. Similarly, here we can get 3 by 2b can be replaced by another constant. Log lambda is equal to a plus. Suppose we consider the another constant d into log e. This is the relation between lambda and e. This is the relation between lambda and r. Okay. This is the basic idea for which transition? Alpha decay. Alpha decay means that this is a loss in atom. Decay means loss. Okay. ये लॉस क्यों कर रहा है एटम? Because it attained the stability. Okay. This much amount of there is a sufficient for set. Okay. Now come to the point. Calculations. Okay. Come to the calculation. अभी तो हमने देखा है कि how alpha particles is emitted from nucleus. Yes or no? And how does this atom become stable? Okay. Now. We can take some calculation for exam point of view. Now this one is different energy levels. Her particle is Zxa. This one in an excited state. Okay, and this alpha particle is emitted. Transition will be take place. Here this atom become Z minus 2 X A minus 4. Means in this case. This atom emitted one alpha particles. We know that this is equal to 2He 4 particle. Okay. How the reaction we can write down? Zxa. Okay. This one is a parent atom. Okay. Parent atom is at a rest. Okay. This atom at a rest. And this emits the alpha particle and becomes another particle. Which one? A Z minus 2 Y A minus 4 plus alpha particle. Alpha 2He4 plus Q. Some amount of energy also released from this reactions. Okay. Now. We can take the law of conservation of energy and law of conservation of momentum. Actually, generally क्या होना चाहिए? Mass of this particle plus mass of this particle is equal to mass of parent nucleus. Yes or no? But ऐसे नहीं होता. Some amount of mass of this one is less than initial mass. मतलब ये mass कहाँ गया? ये जो mass difference रहेगा, वो mass कहाँ convert हो जाएगा? वो energy में convert हो जाएगा. ठीक है? हम first we can write down for law of conservation of energy. Okay, law of conservation of energy. Now in this case, we can use the kinetic energy law of conservation. Okay, Law of conservation of energy means here initial kinetic energy is equal to final kinetic energy. Initial kinetic energy is equal to final kinetic energy. Yes or no? Or we can take Q is equal to emitting energy. Q is equal to EF minus EI. EF minus EI. Means we can write down the final kinetic energy minus initial kinetic energy. Final kinetic energy minus initial kinetic energy. Okay, means Q is equal to, yes, what is the right hand particles? Y particles. Then what is the kinetic energy for Y particles? Is a Ky. Kinetic energy for Y particle is Ky. Okay, next. What is the kinetic energy? K for kinetic energy. Okay, next for alpha particle, kinetic energy K alpha. K alpha. Okay, next. Q is the just energy. This one is not a kinetic energy. This is a general form of energy. Next, minus initial. Initial is this one. Final is this one. Okay, minus kx suppose. Minus kx. But we know that. X particle at rest. X particle at rest. X particle at rest. Then kx energy means kinetic energy of X particle is equal to 0. Always memorize in alpha decay. This initial particle at a rest one. Rest kinetic energy 0. Linear momentum 0. Now means this part is equal to 0. Means final kinetic energy minus initial kinetic energy simply 0. Means Q is equal to, Q value is equal to Ky plus K alpha. Ky plus K alpha. This is the kinetic energy for Y particle. This is the kinetic energy for alpha particles. Okay, now we can use here law of conservation of energy. Now second one, we can apply the law of conservation of momentum. Law of conservation of momentum. What is the law of conservation of momentum? Initial momentum is equal to final momentum. Means Li is equal to Li. Means law of conservation of left side is equal to law of conservation. Momentum of left side is equal to momentum of right side. This is known as law of conservation of momentum. Now here is the X particle momentum. Suppose we consider Px momentum. Which momentum? Px momentum. RHS. Py. For momentum of Y particle. Next one is the alpha particle. Write down the P alpha. Means the Px momentum is equal to Py plus P alpha. Using law of conservation of momentum. Law of conservation of momentum. But we know that X particle at rest. X particle at rest means kinetic energy 0. Kinetic energy 0 only possible. Its momentum is equal to 0. Yes or no? Means the Px value for this case is equal to how much? 0. Why Px is equal to 0? Because initial this particle at rest. Initial this particle at rest. Px 0 means 0 is equal to Py plus P alpha. Py plus P alpha. Means this two momentum is conserved. Means two values are same. How these two values are same? Simple. This magnitude is the same, but sign is opposite. Then and then only this is equal to equal momentum. Yes or not? Take the bar here. Take here bar. Okay. Next, because this one is a vector quantity. Then Py is equal to how much? Py bar is equal to minus P alpha bar. Minus P alpha bar. Okay. Py bar is equal to minus P alpha bar. Now take the magnitudes. Py is equal to magnitude. Py is equal to, yes, minus, Py bar is equal to minus P alpha bar. Minus P alpha bar. And we know that magnitude of positive or negative or real or imaginary, always positive. Okay, and this is equal to how much then? Simply we getting Py is equal to P alpha. We know that mode value always positive. Yes, the momentum of Y particle is equal to momentum of alpha particle. Momentum of Y particle is equal to momentum of alpha particle. What is the two relations? Which two relations? kinetic energy relation. Yes, kinetic energy Q is equal, Q value is equal to Ky plus Ky plus K alpha, and Py is equal to P alpha. K is nothing but kinetic energy of Y particle. K alpha is nothing but kinetic energy of alpha particle. And this particle is a rest. Always memorize. And we know that general formula for kinetic energy. General formula for kinetic energy, P square upon 2m. For Y particle, just take notation for momentum is a Py. Momentum, Py square. Yes or no? Momentum is a Py. This is a kinetic energy depends upon momentum as well as mass also. Okay, means write down here my. Yes or no? Mass is changing, moment kinetic energy also changing. Okay, means here is a Py square upon 2my square. Similarly for alpha particles, P alpha square upon 2m alpha. But we know that relation Py is equal to P alpha, already prove this one. Now substitute Py is replaced by P alpha. Py is equal to P alpha. Then Q is equal to, yes, Q is equal to Py square take common out, P alpha square take common out upon 2. What is the inside? Inside 1 upon my plus 1 upon m alpha into P alpha square upon 2. P alpha square upon 2. Why we can take P alpha square common out? Write down the Py is equal to P alpha. Py is equal to P alpha. Here also P alpha square, here also P alpha square. Then both P alpha square take common out. These two also we can take common out. Then what is the inside? 1 upon my plus 1 upon m alpha. Now our aim to finding the not kinetic energy of now Y particle. First one, finding the kinetic energy of alpha particle. Kinetic energy of alpha particle. Hence, we need to adjust the kinetic energy of the alpha particle. Alpha particle मध्ये कन्वर्जन करायचं असेल तर आपल्याला काय करावं लागेल? m alpha कॉमन घ्यावं लागेल. Okay, means Q is equal to, we can take m alpha is common out, then P alpha square upon 2m alpha. 2m alpha. What is the inside? Inside is equal to, yes, m alpha we can take common out. 1 upon alpha common out. Then this becomes 1 plus m alpha upon my. Upon my. Yes or no? Suppose we can multiply this m alpha inside. Then this becomes 1 upon m alpha. And m alpha get cancelled. Simply we getting 1 upon m alpha plus 1 upon my. Okay. Now next one. P alpha square upon 2my is nothing but, this is nothing but kinetic energy of alpha particle. Kinetic energy of alpha particle. Okay. Means this can be written as K alpha. This is nothing but K alpha. And what is the mass of alpha particle? What is the mass of alpha particle? Mass of alpha particle 4. Mass of alpha particle 4. What is the mass of Y particle? What is the mass of Y particle? A minus 4. Y particle A minus 4. What is the mass of alpha particle? 4 only. Substitute these two values in this equation. Then this become 1 plus 4 upon A minus 4. A minus 4 is the mass of Y particle. A is the mass of X particle. And 4 is the mass of alpha particle. Okay. Now here multiply by A by 4 into divide by A by 4. Then we get in Q is equal to K alpha. Yes. A minus 4 upon A minus 4 plus 4 upon A minus 4 plus on 4 upon A minus 4. Now take here denominator is same. Denominator is same. Means we can take the addition of numerator. Means this is equal to K alpha. This plus 4 minus 4 will cancel. This become A upon here. Denominator is common. Write down here A minus 4. A minus 4. Generally, some exam they ask what is the Q value. What is the Q value? At that time they are given kinetic energy of alpha particle and a mass of parent nucleus. They are given parent nucleus mass and kinetic energy of alpha particle. At that time we need to find out the Q value of this reaction or Q value of this. Okay. Next, or second, they are finding the kinetic energy. How to write down the kinetic energy of alpha particle? K alpha. Here A minus 4 is divided. Going to this side, this become multiplied. A minus 4 अपॉन ए इंटू क्यू और क्यू इंटू ए माइनस 4 अपॉन ए माइनस 4 अपॉन ए. Okay, this is the value of kinetic energy of alpha particle. Kinetic energy of alpha particle. Okay, now here we know that Q value of the reaction and atomic number of parent atom. Then we can find out the directly K alpha value. K alpha is the kinetic energy of alpha particle. This is emitted from the nucleus of the atom. Okay, means how much distance travel of this atom. This depends upon K alpha. What is the kinetic energy of the alpha? Yes or no? Means this is the range is larger. Depends upon the kinetic energy of the alpha. Yes or no? Now next, what is the kinetic energy of alpha? K alpha is equal to simply Q A minus 4 upon A formula. This is always memorized for SET GATE exam. Directly bit question. Simply we substitute the two values, getting the 2 marks. Okay, this is for alpha particle. Now next, finding the Y particles. What is the relation? Q is equal to Ky plus K alpha. Q is equal to Ky plus K alpha. Now we know the K alpha value. Then finding the Q. Q is equal to K alpha plus Ky. Okay, means Ky is equal to Q minus K alpha. Q minus K alpha. What is the K alpha? Q A minus 4 by A. Means this is equal to Q take common out. This become 1 minus A minus 4 upon A. A minus 4 upon A. Now here we can multiply by A and divide by A. Then denominator become same. Then this is equal to how much? A get cancel. This is become 4 upon A. Q into 4 upon A. Q into 4 upon A. Means what is the kinetic energy of Y particle? Kinetic energy of Y particle is equal to Q into 4 by A. Q into 4 by A. This is the final bit. Ky is equal to Q or 4Q upon A. Means they ask what is the kinetic energy of Y particle. Simply substitute the Q and A value. We getting the kinetic energy of Y particle. And for alpha particle, K alpha is equal to Q A minus 4. Q A minus 4 upon A. Means we can substitute here mass of Y particle, here mass of A particle, and Q value. Then we getting kinetic energy of alpha particle. Kinetic energy of alpha particles. Okay, this is the two important formulas for finding the kinetic energy and Q value for different cases of XY particles. A nucleus with a mass number 204 decays by emission of the Q value of reaction is 5.26 mega electron volt. The kinetic energy of K alpha means alpha particle else. Okay, this one is a SET 2013 question. Okay, now here is a so important thing is that always memorize two formulas, otherwise we cannot do anything. Yes or no? Very simple formulas. What is this two formulas? K alpha is equal to Q A minus 4 upon A, first one, and the second one Ky is equal to Q 4 by A. Means in generally in so many exam you can see they ask K alpha value, not a Ky value. Exceptionally maybe 10 or 20% probability to ask the question on Ky. Generally 90% ask one question of the kinetic energy of alpha particle or Q value of alpha particle. Got it? Means here we can memorize these two formulas very simply. How? K alpha is equal to Q A minus 4 upon A. Okay. इसमें होता क्या है? आपको फॉर्मूला याद रहता नहीं, ऐसी कोई बात है ही नहीं, लेकिन कंफ्यूजन कहाँ होता है, ये सबसे इम्पोर्टेंट है. अब जो ये फॉर्मूला है आज याद कर लेंगे, अभी आज के लेक्चर में वो कंफर्म आपके दिमाग में बैठ जाए, कोई बात नहीं है. लेकिन प्रॉब्लम इस बात की है, अब जब कुछ दिन जाएंगे तो ये ऊपर वाला नीचे और नीचे वाला ऊपर हो सकता है. इसमें कंफ्यूजन कब आएगा? जब तक एग्जाम के लिए नहीं जाते तब तो कोई दिक्कत नहीं, कंफर्म आपके दिमाग में फिट रहेगा। लेकिन एग्जाम में बैठते समय तो आपके दिमाग खिल जाता है। तो इस टाइम आपको याद होना चाहिए कि भाई ये ऊपर नहीं है, ये नीचे है। और ऊपर कौन है? a-4, a-4 upon a, in which case k alpha case, k alpha is equal to q a-4 upon a-4 upon a, and ky is equal to q into 4 upon a. Means simply we can find out the k alpha value, we can substitute which q value, and a-4 is the mass of y particle, and a is the mass of parent atom or x atom, mass of a atom or parent atom. Q is equal to simply 4 upon mass of parent atom. Okay, once again to these questions. A nucleus with the mass 204 decay by alpha emission. The Q value of reaction is 5.26 mega electron volt. The kinetic energy of alpha particle is, we know that for alpha particle formula Q a-4 upon a. Means in this case, mass of parent atom. Which atom is a decay? The nucleus with the mass 204 decays by alpha emission. Decays by alpha emission. Means this one is a parent atom. This one is parent atom. Means this is the mass of a particle. So this is the mass of A. Okay. Means A is equal to how much? 204. A is equal to 204. Substitute here. Means K alpha is equal to, yes. What is the value of Q? Q, no confusion. 5.26 directly into A minus 4 means 204 minus 4. 204 minus 4 means this is equal to 200 divided by A. A means which atom is a decay? 204 is decay. Yes or no? Means kinetic energy of alpha part is equal to 5.26 into 200 divided by 204. 204. Always memorize this thing. K alpha is equal to Q A minus 4 upon A, not A upon A minus 4. Don't confuse that. Okay? But once you know the formula, we are getting the answer in a fraction of second. Next, a nucleus having the mass 240 decays by emission of alpha. The ground state of its daughter nuclei, alpha emission. Okay, alpha emission to the ground state of the daughter nucleus. The Q value of the process is a 5.26 mega electron volt. The energy in a mega electron volt of the particle is again we can find out the K alpha energy formula. K alpha is equal to Q 1 minus 4 upon A, or we can write down A minus 4 upon A. Now, what is the given data? Here, mass of parent atom means here, this one is parent atom 240. Okay, decay into daughter atom, suppose Y 236 plus 2He4 plus 2He4. This is the kinetic energy of alpha particle. Okay. Now K alpha is equal to, yes, Q is equal to how much? Here Q value given. The Q value of the process is 5.26 into 1 minus 4 upon 240. Yes or no? 0 as it is. 4, 24, 6. Okay, this is equal to how much? 5.26 into 1 minus 1 by 60. Yes or no? 4 by 24 by 4, 6. Okay, this is equal to K alpha is equal to 5.26 into 1 by 50, 1 by 60, 1 minus 1 by 60 means 59 upon 60. Yes or no? Means this is approximately equal to 1. This is not approximately exactly 1. but this is close to the 1, close to the 1. म्हणजे this is a less than 1. म्हणजे less than 1 आहे. So we can multiply by this number. Again, this number getting slightly lower value. Okay, lower value. Then we can solve this one. We can multiply this one. We getting K alpha is equal to 5.1723 value. 1723 value. Yes or no? This is a very important thing. Okay. Now here, all options are very close. Here 5, 5, 5, 5. Okay, means here we need proper calculation. No excuse at all here. See here 5.2 and here is a 5.0. Suppose this option is very large from actual answer, but these two option is very close to each other, very close to the each other, because 17 and 13 are very close. Hence we need to proper calculation. Yes or no? This proper multiplication is important here. Once we calculate this one, we getting the proper answer, exactly answer for this question. Here, what is the important things? Important thing is the both formula is important. K alpha is equal to Q A minus 4 upon A. And second, Ky is equal to Q 4 by A. Don't miss A upon A minus 4. This is not A minus 4, A upon A minus 4. A minus 4 upon A. Next problem. The disintegration energy is defined to be difference in the rest energy between the initial and final states. Consider the following process. Which process? 94 Pu 2402 92 U 236 plus 2He. This process is known as alpha disintegration. Yes or no? Alpha disintegration. Okay. And the alpha particles has the kinetic energy is equal to how much? 5.17 mega electron volt. The value of a disintegration energy. The value of disintegration energy means which energy? Disintegration energy is nothing but Q value. This is nothing but Q value. Q value and disintegration both are same. Both are same. Okay. And we know that one formula. K alpha is equal to Q A minus 4 upon A. A minus 4 upon A. एकच formula लक्षात ठेवा. Don't memorize both Q and K alpha formula. मग त्या केसमध्ये तुमचं कन्फ्युजन होऊ शकतो. Okay, K alpha is equal to Q A minus 4 upon. Now our aim to finding the Q, not the A. K alpha. Q is equal to yes. Then this is equal to how much? Now A upon or K alpha upon. K alpha upon 1 minus 4 upon A. 1 minus 4 upon A. Yes or no? And this can be written as K alpha upon 1 minus, yes, 4 upon, what is the value of A? Yes, 240. A is equal to how much? 240. A is equal to how much? 240. Means Q is equal to K alpha. Write down 1 plus. Why we can take the plus? Because here 4 upon 240, or we can increase one step here, minus 4 upon 240. 4 upon 240 means 1 upon 60. 1 upon 60 into how much? 1 upon 60 into 1 minus 1 upon 60, bracket is 2 minus 1, bracket is 2 minus 1. Okay. Now second part is the less than 1. Second part is the less than 1. Less than 1. We can apply the binomial distribution. Binomial 1 minus x bracket is 2 n minus n or plus n, whatever. This is equal to 1 plus nx or 1 minus nx. Well, both sign is minus, we are getting the plus. Here is minus, here is the plus, we are getting the minus. So okay, means Q is equal to K alpha 1 plus 1 upon 60. 1 upon 60. Yes, sir. Then this is equal to how much? K alpha 60 plus 1. 61 upon 60. 61 upon 60. What is the value of K alpha? K alpha is equal to kinetic energy of this is equal to 5.17. 5.17 into 61 upon 60. 61 upon 60. 61 upon 60 is a definitely greater than 1. Definitely greater than 1. Yes or no? Definitely greater than 1 means this is multiplied by this value. This value is increasing. This value is increases. Yes or no? In the last case, 59 by 60, at that time this quantity is slightly smaller than 1. This quantity is a decreases. Okay? This quantity multiplied by greater than 1 or 1. Greater than 1, this is a definitely increase. Less than 1, decreases by 1. Means here we can properly solve. We getting the 6 mega electron volt, 5.26 mega. This is the same problem of the last one. Yes or no? Last case मध्ये काय दिलं होतं तुम्हाला? Energy विचारली होती. What is the kinetic energy of alpha particle? And remaining all data are given. Yes or no? In this case, 5.26 also given. And at that time, we getting the answer is equal to how much? 5.17. Okay. Sometimes this question also asked on this exam. Fission fragments are generally radioactive as fission fragments are generally radioactive as they have excess of neutrons, they have excess of proton, they have a product of a radioactive nuclide, their total kinetic energy is of order of 2 mega electron volt. 2 mega electron volt. Radioactive always condition is memorized. What is the radioactive condition? N upon Z is greater than or equal to 1.5. Greater than or equal to 1.5. Means in this case, which part is excess? Neutron is excess. Neutron is excess. Then we can say that this one is a radioactive in nature. This one is a radioactive in nature. Why? Because of the condition N upon Z is greater than or. Next question. Which of the following phenomena can be explained by quantum mechanical tunneling through the barrier, of alpha decay field emission e to the power minus s from a metal surface, and third one is a beta decay. Okay. Now in this case we are given some options. Okay, but always memorize. Not only tunneling, only focus on alpha decay. Yes or no? But this effect also getting the tunneling effect. Got it? Field emission of e to the power minus s from a metal surface. This also getting tunneling effect, or beta decay also explain the tunneling effect. Got it? Means tunneling, these three effects can be explained. Next, consider the alpha decay reactions. Polonium decay into which one? 206 plus helium atom, where the atomic mass are mass of polonium and mass of lead is a 20386. Mass of helium is 4.003 times, and 1 me is equal to 1.141. Okay, and the kinetic energy of alpha particle. Okay, we know that law of conservation of energy. We can take Q is equal to mass of reactant minus mass of product. Mass of reactant minus mass of product into C square. Always memorize a reactant mass is always greater than mass of product. You know that a reaction, suppose ZXA, alpha particle is emitted, then this becomes Z minus 2, Y A minus 4 plus 2He4 plus Q amount. Okay, Q amount means this much amount of energy is liberated from this reaction. Means this energy, how to convert this energy? Because of this mass difference. Means we can take the masses of this and masses of the parent. We can take the difference of this one. This much amount of energy is created. Yes or no? Means this mass is always greater than mass of these two nuclei. Okay. Now in this case, what is the reactant? Reactant means here parent. Mass of polonium. What is the mass of polonium? Mass of polonium is equal to 210.2 0.0483 minus mass of reactant. Mass of reactant lead 206.0386 minus mass of helium. Mass of helium 4.0039. Okay, into C square. Okay. We can find out this difference is equal to how much? 0.0058. We can calculate this one. We getting this one 0.0053, and write down the C square value is equal to how much? 931.5 mega electron volt. Okay. We can multiply this into this. We getting 5.4 MeV. Means which option is correct one? Here 5.4 keV, 2.7 keV, 5.4 MeV, 10.8 MeV. Means here two options are matches. 5.4, here also 5.4. But here always memorize 931.5 unit is mega electron volt, not a kilo electron volt or electron volt. Means which option is correct? 5.4 mega electron volt. Got it? Means sometimes they are given masses, and at that time they ask what is the value of Q. What is the value of Q? Or sometimes they ask what is the kinetic energy. What is the kinetic energy? Then they ask kinetic energies. Okay. Q into this one. Okay. Next. Sorry. I can directly answer here. This is getting Q value. Okay. Q is equal to, I think, slightly small difference is here. We're getting some value into this into this. Next. Okay, suppose Q is equal to, find out this value, and we know that K alpha is equal to Q into yes, formula A minus 4 upon how much? A minus 4 upon A. Whatever the value, write down here, into A minus 4 means 206 upon 210. We can solve this one. We getting answer is equal to how much? Answer is equal to for this case, answer is equal to 5.4. See, option number which one is correct? Mega electron volt. Not all times they are given only Q value and A value, just alike. Find out the K alpha value, kinetic energy of alpha particles. Sometimes they are given masses. How to find out the Q value in this case? Mass of reactant minus mass of product. But here mass of reactant is only parent nucleus and product is a daughter nucleus. Take the mass of reactant minus mass of product into C square. Write down the C square value is equal to 931.5 mega electron volt. Unit is a mega electron. Which of the following decays chain is possible to observe? Which of the following decay chain possible to observe? Okay. मतलब कौन सी chain possible है observe करने के लिए? This one is a radioactive case. Okay. Here we can study the alpha, beta and decay case. Okay. Here is alpha decay. Alpha decay, we know that is alpha decay. Atomic number is increased by 2 unit and mass number is increased by 4 unit. In beta decay, mass number does not change, but atomic number is increased by 1. Or gamma decay, mass number or atomic number does not increase in this case. Okay. Now, see first one, 82 to 80 means there is no increase 2, not increase 2. Yes or no? Means atomic number does not increase here by 2. Here mass number is decreased by 4, no problem, but atomic number does not increase by 2. And here also 202 to 202, mass number does not change, but atomic number does not increase by 1. Does not increase by 1 means here is not a beta decay is possible. Okay, means this one is not belongs to the alpha or beta. This one is not correct. Next, 88 to 86. Here atomic number is decreased by 2 and mass number is increased by 4. Mass number decreased by 4 and atomic number decreased by 2. We need increase by 2. We increase by 2. Then we can say this one is a alpha emission. Second, 86 to 82, no any relations. Okay. This is also not allowed. Alpha particle is a decay. Atomic number increased by 2 and mass number increased by 4. Beta decay, atomic number increased by 1 and mass number as it is. 82 to 80, 202. Here mass number decreased by 4, no problem here, but here atomic number is not increased by 2. Decreased by 2, okay, yes. Mass number is decreased by 2, yes. 80, 88 to 86, yes. Mass, atomic number is decreased by 2 and 2, 4. Here is the one alpha particle is emitted, no problems. 2 particle is emitted here, no problem. Okay. But here 86 to 82, here we need to increase the atomic number. Then we can say this one is alpha decay is possible. Or here is no sequence. Suppose we can say that again alpha particle is emitted. Then atomic number is decreases. Yes. But here 210 and 207 is not correlate with 4. Got it? Means this also not correct. Next 82 to 80, yes. 20 to 2 means one alpha particle is emitted. But here we need to increase one atomic number, but here one atomic number is decreases. Means the first one is allowed, but second part is not allowed. Means total series not possible. Next, 83 to 210, 83 to 210. Here is 84 and mass as it is. Means one beta particle is emitted. One beta particle is emitted. Atomic number is increased by 1. Okay, and here is 84 PO 210 to lead. Here mass number, atomic number is decreased by 2 and mass number is decreased by 4. Means here is one beta particle is emitted. Means which of the following series is possible? This series is possible. Got it? Using the alpha and beta. Next, find the kinetic energy of alpha particle in alpha decay. Same. First we need to find out the Q value. Q is equal to mass of reactant minus mass of product into 6 square. Okay. Mass of reactant. In this case, radium is a reactant. Means 226.025403 minus mass of product. Means here is a Rn is a, this is equal to how much? 0.1757 minus 4.00 2603. This difference getting 0.0052229. Okay, but this is in the form of AM. Got it? Next, Q value is equal to this one. Next, our aim to find out the K alpha. Then K alpha is equal to A minus 4. What is the value of A here? A is equal to here A is equal to 226. Means 226 minus 4 upon 226 into Q value is equal to how much? 0.0052229. Okay, we can take multiplication of this one, then this getting 0.9823 into, yes, 0.005229. Okay, and we can multiply these two terms, and AM is converted into mega electron volt by multiplying by 931.5. Then we getting answer 4.78 mega electron volt, not a milli electron volt or kilo electron volt. Answer is getting mega electron volt. Means simply here we can find out mass difference, then multiplied by 931.5. Means this can be converted into mega electron volt. Next we can find out the K alpha is equal to A minus 4 upon A into Q value. Now what is the velocity of alpha particle? Velocity of alpha particle. Okay. Velocity of alpha particle. Okay. Now, suppose m is the mass of alpha particle. M is the mass of alpha particle. Q is the charge of alpha particle. Q is charge of alpha particle. and r is a radius of track. R is a radius of track, and B is the magnetic field. B is magnetic field. Okay. Then velocity for alpha particle is equal to QB r upon m. Okay. This is the velocity of alpha particle. This is the velocity of alpha particle. Okay. Alpha particle. Next, a range of alpha particle. A range of alpha particle. Okay. What is the range of alpha particle? The distance through which an alpha particle travel in a specified material before stopping to ionize. Okay, is called a range of alpha particle. Okay, range of alpha particle. Means suppose we know that this alpha particle emitted from the nucleus. Okay, once you cross the radius of the nucleus, then this alpha particle ionize the mode. Ionization will be start. Yes or no? Suppose this one is the atom radius. Once you cross this radius, then this point 2 up to stop the alpha particle, this helium atom is ionize the medium. Yes or no? Now this is known as this length is known as the ionization length. This is a depends upon which factors? This is the depends upon energy, initial energy of alpha particle. Means initial energy of alpha particle is larger, then ionization is taking more. Yes or no? Means this is the depends upon energy of initial alpha. And second one, next medium also important. Yes or no? Means here collision between alpha particle and nature of the gas. Next, means here whatever the nature of the gas and alpha particle collision, this relation also important. Next, temperature, pressure of the gas, pressure of the gas. Okay, means here pressure of the gas is or medium. Pressure of the gas is larger. Pressure is larger. Then velocity of the alpha particle is decreases. Velocity of the alpha particle is decreases. Yes or no? Simply pressure increases, velocity decreases. Next, temperature. Here temperature of the gas in between this region increases. Temperature increases. Then a range. This path length is increases. Yes or no? Means here is a depends upon temperature, depends upon pressure. Pressure increases, path length decreases. Temperature increases, path length increases. Initial kinetic energy increases, path length increases. Yes or no? Now this helium ionize this medium. Yes or no? Means again we need one concept also important. Which one? This is a specific ionization. Before specific ionization, we can study what is the relation between a range and velocity. Okay. Range and velocity relation. Generally, for few medium, range is directly proportional to velocity q. Range is directly proportional to velocity q. Not all cases this one is allowed. For some cases, r is directly proportional to v to the power q. V means velocity, r means range. And we know that general energy is equal to how much? 1 by 2 mv square. Yes or no? Means here v cube is equal to, yes, v cube is directly proportional to r. Means v is directly proportional to r to the power 1 by 3. But our aim to find out the v square. Then v square is directly proportional to r to the power 2 by 3. R to the power 2 by 3. Yes or no? Means energy is directly proportional to r to the power 2 by 3, or range r is directly proportional to e to the power 3 by 2. E to the power 3 by 2, or here r is equal to some constant into a to the power 3 by 2. Okay, this one is a range. R and E relation. Okay, means r is directly proportional to e to the power 3 by 2, or v square is directly proportional to r to the power 2 by 3, or r is directly proportional to e to the power 3, e to the power 3. Next, specific ionization. What is meant by specific ionization? The number of ions pairs formed per unit length at any point of alpha particle is called a specific ionization. Specific ionization. We know that E is directly proportional to r to the power, yes, r to the power 2 by 3. Okay. Here is the rate of change of energy per unit length. Per unit length means r is equal to how much? 2 by 3. Directly proportional to r to the power minus 1 by 3. Minus 1 by 3. Which is directly proportional to 1 upon nu. 1 upon velocity. 1 upon velocity. Okay. Next, last one. Giga-Newton law. This law is related with lambda. This is related with the lambda. Log lambda is equal to a plus b l log r. Means this is the relation between lambda and r, or this is the relation between log lambda a plus substitute the r value e to the power 3 by 2. 3 by 2 coming here, b into 3 by 2, getting some constant. Suppose we consider the d into log. Means here this one is the relation. This is actually lambda. Lambda is changing, these two quantity also changing. Means range also changing, energy also changing. This is the all things for only set exam. Okay, set point of view, alpha, decay,